Hi everyone. Today we're going to talk about three-dimensional coordinate systems. And all the graphs we have seen before, they are in two-dimensional coordinate system, right? They are either in a xy plane or they could be the polar coordinates r theta, right? These are two different kind of coordinate systems. We have the Cartesian coordinate system, the rectangular coordinate system, and the polar coordinate system, right? Both of them are two-dimensional because we only have two different directions. We are looking at two different variables are used for the coordinates of that point. Right? Now we're going to look at three-dimensional coordinate systems now. This is really important because in reality, everything is in three dimension, right? If we just look at a plane, a xy plane, it doesn't help us a lot to analyze real life situations because other than the x and the y direction, we need another z direction. The whole three dimensions gives us the full picture of things we want to study in real life. Right? So for a three-dimensional system, one way to think about it is just that we're adding another z-axis now, right, to the xy plane we already have. And this z-axis should be perpendicular to my xy plane here. Right? So in my picture on the left, this three-dimensional system comes from laying down my xy plane flat and add another z direction that's vertical, perpendicular to that xy plane. That's a three-dimensional coordinate system, right? However, you may be thinking that why can't we do this, like x facing the right direction, y goes this way like what we normally would, and the c comes out like this. This is still a three-dimensional coordinate system, right? We still have three different directions. Or why don't we have x goes up, and then why don't we have x goes up and the y here, and or c here, and the y comes out, right? Why do we particularly choose this picture here on the left to be our three-dimensional coordinate system? Well, this is because even though any kind of arrangement of these three different directions would be fine to be a three-dimensional coordinate system, but people want to actually know what other people are talking about without getting a bunch of introductions on which direction is which variable, right? So it's easier if everybody just coming to agreement on what kind of directions we're using. And how people decide on this is this right hand rule. So if we use our right hand, so get your right hand out, and then just pointing your right hand on this xy plane first that we already have. So what I'm going to do is to have my right hand out with my four fingers flatten out. So my four fingers are straight out from my four fingers are extending straight first. And these four fingers are going to point toward the direction of the x-axis. Okay, so in my picture here, my four fingers are pointing this way first in the x-axis direction. And then I'm going to curl my fingers. So we curl the fingers in this way so that they are going to point to the y-axis direction. Right, so my four fingers are straight, pointing x directions first. Then I curl it to point to the y direction, and then the direction your thumb is pointing to is exactly this z direction. Okay, that's how people define a canonical three-dimensional coordinate system using x, y, and z. So if you look at my picture right here now, if my x is going to the right, my y is pointing up. Using my right hand, you can use your right hand. First, my four fingers needs to point to the x-axis direction. Right, so my hand should go this way. My four fingers pointing to the positive x-axis. And then my four fingers need to curl to point to the y direction. And if you try to do that, to think about how you can actually curl your four fingers from x to y, the only way we can do it is to have our thumb to point out of the screen. Right? Our thumb have to be perpendicular to this xy plane and point out of it instead of going into it. Right? That's the only way we can naturally curl our four fingers, so we know our Z direction would be the one coming out now. Okay? And then similarly, if we look at another example, let's say my x-axis is this way and the y-axis is this way. If this is how we drew our x and y, which direction should our z point to? Well, if you think about this, first of all, my four fingers need to point to the x-axis, and then I need to curl them to point to the y-axis. And the only way I can curl them is that if my thumb is pointing into the screen. Right? If my thumb is pointing out of the screen, there's no way my finger can curl. I'm not that flexible. Right? And my hand have to have the thumb pointing into the screen so that my other four fingers can go from x-axis to y-axis. Right? So in this case, my C should go into the screen, something like that. Okay, so that's how we define our order of the x, y, z axis. And normally when you think about this x, y, z three-dimensional coordinate system, what you want to think about is the left bottom corner of your room here. So let's say you are in a rectangular box room. Right? It cannot be any irregular shaped room. It have to be like a rectangular box. And now, standing in the middle of your room, you choose a wall to face to. Okay, so just think about you're standing in the middle of the room, facing a wall in the room. Then the left bottom corner of that room, that direction you're facing, is exactly this corner of the XYZ coordinate system. The floor of your room is exactly this XY plane. That's where both X and the Y axes are at. The wall you are facing is where the Y axis and the Z axis are at, right? That's the YZ plane. And the wall to the left of you is where the X axis and the Z axis are at. That's the XZ plane. Okay, so just think about you're in a room and look for that bottom left corner that's facing you. That's exactly this corner XYZ plane we're looking at. And this point here, where the three axes intersect, again, this is called the origin. And this point, we can give it coordinates. And because this is a three-dimensional coordinate system, we need to have three coordinates now, right? We need the three numbers for them. And my first coordinate, again, like normal, it's the x coordinate. My second coordinate is the y coordinate, and then now we added the third direction. The third coordinate will be the c coordinate. The third direction, right, will be the c coordinate here. And my origin here, that's where x is 0, y is 0, c is 0. That's where they all intersect with each other, right? So a point in my three-dimensional plane, three-dimensional space would actually have 3 coordinates now. Okay, so in general, if we're looking at a point x, y, z, this point means in the x direction we moved x units, right? And in the y direction we moved the y unit, and in the z direction we moved the z unit. So when you think about this kind of point x, y, z in the three-dimensional space, think about this rectangular box again with one of the corner exactly at this origin 0, 0, 0. Let's start here and see where we can get to using this x, y, z coordinates. The x coordinates, again, that means following the x direction, I'm going to move for x units, right? I get to here. Then the y coordinate means following the y direction, I need to move y units. And my y direction is towards the right? So if I'm here, I'm going this way now for y unit. That's my y direction. I end up here. Now z direction is the vertical one. So here, if my z is positive, I'm going to go up, right, for c unit, and I end up at exactly this point, x, y, z. Right, so any point x, y, z just means the x coordinate in the x direction, that's x units, right? In y direction, we move y unit. In the z direction, we move z units. And you can do them in different order as well, right? You can move in y direction for y units, then in z direction, then in x direction. It doesn't matter how you move, right? As long as you follow those number of units in each direction, you will get to the exact same point, x, y, z, we want to find. Okay. Now, using this three-dimensional coordinate system, we're going to have these 3 basic plane now, right? I actually mentioned it a little bit earlier. This xy plane is exactly where our floor is in our room. This yz plane is where the wall we are facing in the room. This xz plane, this purple one, is the wall to the left of us in the room. Right? And for each of these planes, we actually have special equations and special coordinates for them. If you think about the point in the xy plane, what's the coordinates for this point? Well, remember we just talked about it. For finding the coordinates, we need to follow x direction, right, for x unit, then follow y direction for y unit. And you can see we get to exactly this point now, right? We do not need to follow any z directions. The z direction actually only moves 0 unit because we're not going up or down. We're exactly at this xy plane, exactly where this floor is. Right? So for xy plane, the equation of it is z equals to 0. Our x-coordinate of the point can be any real numbers, negative infinity to infinity, right? Depending on how many units we move. Our y-coordinate, again, can be any real numbers, but our z-coordinates have to be 0 so that we're still staying on that floor at the xy plane. Right? Similarly, for the yz plane, any point here in this orange plane, it should have the x-coordinate to be 0 now. Right? Our y-coordinate can be anything, z-coordinate can be anything. We can go any units in the y and the z directions, but we cannot go any unit for the x direction. Our x have to be 0 in order to stay in this YZ plane. Right, so my first coordinate in the point is 0. YZ can be any numbers. And in the XZ plane, so this purple plane, that's our left wall, X and Z coordinates can be anything now, but Y has to be 0. Right, so my second coordinate for the point is 0, and the first and third coordinate could be anything. Okay, so that's some basic equations you should know. Now when we say one variable equals to 0 or one variable equals to a number, we're talking about these kind of plane now. They could be vertical or they could be horizontal, right? It depends on what variable we're talking about. And these three different planes actually divide the space into 8 regions. They are called the octants. So let's look at the picture here. That's the green plane is my XY plane, right? That's our floor again. The orange one is the YZ plane. The purple one is my XZ plane. And you can see these 3 planes divide my whole space into 8 different regions. And we are in this room right here. That's the first octant where X coordinate, Y coordinate, and Z coordinate are all positive. Right? If you think about the room behind the wall you are facing, then Y coordinate would be X coordinate would be negative. That's a different octant. And if you think about the room below you, then Z would be negative. That's a different octant, right? And there are 8 of them in total. Okay. Now another thing we need to know is that this equation x equals to 0 we just talked about, it can represent different things now. Right? It depends on which space you are looking at. When we say x equals to 0 in a one-dimensional space, we're talking about a number line. Right? That's only one dimension, from negative infinity to infinity. If x is 0, it is only a point. However, if we look at x is 0 in a two-dimensional space, in this xy plane, x is 0, but there's no restriction on y. Y could be anything, so it's actually a line now. Right, and the equation of this line, that's where my y-axis is at, is exactly x is 0, because every point here have the x-coordinate to be 0 and the y-coordinate could be anything. Right? Now in three-dimensional space, that's what we just looked at, x equals to 0 means a plane now, right? Because only x is restricted to be 0, but y can be anything, z can also be anything. So overall we have this two-dimensional space. As long as the x-coordinate is 0, this whole thing has the equation x equals to 0. Okay,